Hello student, I am Rohit from Find Your Genius Academy. Today I will discuss you the next topic, electric field intensity at a equatorial line. Now we will start. First we know about the what do you mean by equatorial line? The equatorial line The equatorial line of the dipole is a line perpendicular to the axial line and passing through a point midway between the charges. Means the equatorial line, this is the P point and it's perpendicular on the axial line. Clear? And this is a dipole. This is the axial line passing through the midpoint of between the charges. This is minus q charge, this is plus q charge, and here the midpoint O. Here the midpoint is center of the dipole. This is known as a dipole and its center is O. Clear, student? Now consider dipole consisting of a minus q and plus q separated by a distance 2a. The two charges, this is minus q at point A and this is plus q at point P, it's separated a distance 2a. Now the distance between the point A to center O is small a, and here is also be small a. Now consider an electric dipole A and V. Let PV the equatorial line at distance r from the center O of the dipole. Here the P point and here the placed the unit positive charge at point P from the center O. The distance is small r. The unit positive charge is placed at the point on P. Now the electric field intensity at the point P is. Now we find the electric field intensity at point P. Now here see the diagram. Here the charge minus q at point A. Now the electric field is here EA. This is the negative charge, and we know that the electric field direction for a negative charge, electric field direction for a negative charge is always inward. Now the electric field direction is always inward. Now here the angle, here the angle is theta, here angle is theta, it is also be angle is theta, and this angle is theta, and this is also be theta. The total angle is 2 theta. Now here the electric field at point V, the charge is plus q. Now we know that the electric field direction for a unit positive charge is always outward. Now the direction of the electric field at point B is EB. Clear? And the direction is always outward because this is a positive charge. Now here at electric field at point P is the sum of the two electric field at point A and electric field at point V. Now here we see the electric field at point P is equal to EA plus EV. Now the vector sum of EA and EV are acting at an angle of 2 theta. Now the vector sum of these two electric field forces is angle is here theta and here is also be theta. Now total angle is 2 theta. Clear, student? Now next the resultant intensity is the vector sum of the intensity along PA and PV. This is point P. Here see the diagram. This is PA and this is PV. Now electric field density at along this component here, this PA and PV. Now EA and EV can be resolved into the into vertical and the horizontal component. Here the angle is theta, and we know that the angle is theta is made in this point. Now this is the E cos theta and this is also E cos theta, and now this is E sin theta and this is E sin theta. Now the electric field is resolved into two component, E cos theta and E sin theta. Clear? Now here this E sin theta and A sin theta and EV sin theta is cancelled to each other because because they are opposite to each other. Here they are cancel each other, they are equal and opposite direction. Now only we here the component only we present E A cos theta and E B cos theta is only be present here. Clear? Now the electric field at point A. Now the electric field at point A we know that the electric field is 1 upon 4 pi epsilon naught q over r square. Now see the diagram. Here the r square means this is A, this is r, and this is the distance A to P. Now here this is hypotenuse means h. Clear, student? And we know that h square equal to perpendicular square plus base square. Here h square is equal to AP square. Here see the diagram and the value of the P. Now the value of the P perpendicular and the perpendicular this the value of the perpendicular is r and the value of the base is small a. No, the value of the perpendicular is small r. Here the value of the perpendicular is small r and the value of the base is small a. Clear? Now the AP square is equal to r square plus a square. Now the putting the value of the AP square is here. Now the result is EA electric field at point A 1 upon 4 pi epsilon naught q over r square plus a square. Clear? Now similarly the electric field at point B is 1 upon 4 pi epsilon naught q over BP square. Now see the diagram. This is BP, this is also be h. Hypotenuse means the base we find the value of h square is equal to hypotenuse h square is equal to base square plus perpendicular square means r square plus a square. Now putting the values here. Now EV is equal to 1 upon 4 pi epsilon naught q r square plus a square. Clear? Now here the electric field E is equal to, now we use the parallelograms law. E is equal to E square is equal to E A plus E A का square plus E B का square plus 2 E A E B cos of here the angle is 2 theta. Now we know that the electric field at point A and the electric field at point B is same. Now the electric field at point A equal to electric field at point B equal to similar. This is known as EA. Clear? Now putting the value in our equation. Now E square is equal to E A square plus, now the putting the value of EV is equal to EA. Now EB square. Now here EA. Now here the 2 into EA into EA into cos of 2 theta. Clear, student? Now here this equal to, this is 2 time of EA square here plus this is 2 time of EA square into cos of 2 theta. Clear, student? Now here this is equal to, this is 2 E A square is common. Now in 1 plus 2 cos 2 theta, and we know that the value of 1 plus we know that the value of 1 plus cos 2 theta is equal to 2 cos square theta. Now the putting the value is here. Now the putting the value of here, this is equal to 2e square into here the value is equal to 2 into cos square theta, and this is equal to E electric field at point P ka whole square. Now this is the square, and now this square is goes to this side, then it's under root. Now this is 4e square into cos square theta. Clear, student? E P square. Now this square is goes to this side, this is whole under root. Now whole under root means here, now here 4 e square a into cos square theta here. Clear, student? Now this is 4 come out from the under root, this is 2, and the square is cancelled out to the under root. Now my final result is 2e a, and cos square is come out from the under root, then this is also is a cos theta. Now this is equal to E P. This is our expression, final result. Now next, here we know the value of EA. We know the value of EA value is equal to 1 upon 4 pi epsilon naught into Q R square plus A square. Now putting the values here, now this is our expression, this is cos of 2 theta is this equal to, our expression is equal to E 2EA cos of theta. Now we find the value of cos theta. We find the value of cos theta. We find the value of cos theta. Now see the diagram. Here. Now the triangle OPA. Now triangle OAP equal to, means cos is equal to, cos theta is equal to base upon hypotenuse. From, see the diagram here the base is A and h is r square plus a square cos theta. Now we know that the formula of cos theta is equal to base upon hypotenuse. The base is equal to, from the diagram, from the triangle, our triangle is OAP. Here the base is A and the hypotenuse is under root r square plus a square. Now we find the value of cos theta. The value of the cos theta is equal to a over under root r square plus a square. Now we put the value of cos theta in above equation. EP equal to 2 times of A into cos of theta. Now here putting the value of putting the value of cos of theta and E is equal to 1 upon 4 pi epsilon naught into Q over value of the cos theta is equal to, cos theta value is A over under root r square plus a square into 1 upon r square plus a square. This is the value of EA. EA is equal to 1 upon 4 pi epsilon q over r square. R square is equal to a r square plus a square, and the value of the cos theta is here. Now here the value of EP equal to 2q into a over, a over here 1 upon 4 pi epsilon naught into base are same, the power will be added. Here the 1 by 2 and here the power is 1. Now the base are same, power will be added. The total power is here r square plus a square. The base are same, power will be added. Here 3 by 2. Clear. And we know that the dipole is equal, P is equal to Q into 2A. Here now this is Q and this is in the form of we write in this form. Now EP equal to Q into 2A over 4 pi epsilon naught into r square plus a square raised to power 3 by 2. Now here we see, here this is putting the value of the cos theta, and the cos theta here we substituting the value of the cos theta a over r square plus a square raised to power 1 by 2. Now here we know that the value of E electric field at point A is equal to Q of 1 upon 4 pi epsilon naught into Q over r square plus a square, and the cos theta value is a over r square plus a square raised to power 1 by 2. Now here the base are same, power will be added. This here the power is 1 and here the power is 1 by 2. Now the power is added, 1 plus 1 by 2 is equal to 3 by 2. Now here we know that the P is equal to, P equal to Q into 2A. Here this is Q and this is 2 into A. Now this is equal to P. Now in next step the K is equal to this 1 upon 4 pi epsilon naught is known as K, means the value of the K is equal to 1 upon 4 pi epsilon naught. Now and the value of the P is equal to, P is electric dipole, the Q into 2A. Now here the final result is equal to E is equal to KP r square plus a square raised to power 3 by 2 along PX. Now as a special case is, we find at very far point, that is 2A is very less than R, means the dipole is very small as compared to P point. Means here see the diagram here, means this distance is very small, dipole is very small, and the unit positive charge is placed is very far away. Now then this distance A is neglected. Now here the value of A is neglected. Now our result here this is equal to E equal to KP over a is neglected, then a is equal to 0, then this is equal to 3 by 2. Now the power is cancelled out by this 2 is cancelled out by 2. Now our final result is equal to E electric field at point P equal to K P over R cube, means the electric field at a equatorial line is inversely proportional to electric field at point P is inversely proportional to 1 upon R cube, 1 upon R cube. Now here this is the final expression. Now we know the value of the electric field at a equatorial line is equal to E is equal to Kp over R square plus A square raised to power 3 by 2. And our last expression is equal to electric field at the axial line. The final result is equal to E on the axial line is equal to 2 times P over R square plus A square into raised to power 3 by 2 into K. Here the K, here the K. Now this is the 2 time of a equatorial line, means this is the 2 time of equatorial line, means this is the axial line. The axial line expression is equal to 2 time of a axial line equal to 2 time of a equatorial line, equatorial line, means our expression for the equatorial line is equal to Kp over R square plus A square raised to power 3 by 2. Now our result, now this is a relation between the axial line and the equatorial line. This is the important result in exam point of view, because the on objective type question is asked in many times. Now here the relation between the equatorial line equal to half of axial line, half of a axial line. Clear student? This relation is very important. Now next, if the observation point is far away or when the dipole is very short, then the electric field intensity at a point on the axial line is double the electric field intensity at a point on a equatorial line. Here we know if the observing point is very far away and the dipole is very short. Now we find the result, E axial line is equal to 2 times of the equatorial line. Now the direction of the electric field intensity at a point on equatorial line due to a dipole is parallel and the direction of the opposite to the direction of the dipole moment, means the electric field intensity at a point of the equatorial line due to a dipole is parallel and opposite to the direction of a dipole moment, means the direction of the dipole moment. What do you mean by a dipole? Dipole is consisting of the two opposite charges, means minus, and this is charge here plus, this is called dipole. The direction of always dipole is minus 2 plus the dipole direction is always here. Now the electric field is electric field intensity is opposite the direction of a dipole moment. That this is dipole moment, here the dipole moment, and it is opposite to the electric field intensity direction. Clear student? If you have any doubt in this lecture, you will comment on this comment section and your doubt will be discussed in the next video. Thank you friends, thanks for watching.